We're going to talk about EIGRP. We're going to talk about it for version 4 and version 6. The objective, I'm going to talk about the features and operation of EIGRP. We're going to talk about the different packet forms. We're going to talk about diffusing update algorithm or dual algorithm. Talk about its concepts and operation. Then we're going to do commands to configure and verify basic IPv4 and IPv6 EIGRP. Okay. EIGRP was created and released in 1992, and in 2013 the basic standard of it was, or the basic functionality was released as an open standard. That means it's no longer Cisco proprietary. And they added the Advanced Distance Vector Routing Protocol. Okay, that's what it is. What is the Distance Routing Protocol? Distance Vector Protocol? Anyone remember from RIP? Going once, going twice. RIP is a Distance Vector Protocol. That means the metric, the hop count, if you will, is by distance. So if I'm going to try to talk to Adriel, I've got to go through Derek. So my hop count would be 2, right? So the distance is assigned to the speed. Okay, diffusing update algorithm calculates paths and backup paths, establish neighbor adjacencies, which is similar to your Cisco Discovery Protocol or CDP. Use reliable transport protocol to provide delivery of the EIGRP packets to those neighbors. And then does partial and bounded updates, and then equal and unequal cost. Okay. There are 3 different types of things you need to look at. We have a next hop router that's going to be on the interface, right? These are what we call protocol dependent modules. 3 different modules. It's depending on your neighbor and the interface it goes out. If I'm looking at the topology, I'm looking at how is it going to get there? What's my destination? And if I'm looking at my routing table, what's my destination? Okay? Reliable transport protocol looks at each one of those to determine which one's going to be the best way to get from one end to the other. Now, the protocol, the PDMs operate at the application layer of the OSI model. Okay? RTP, which is a reliable transport protocol, replaces the TCP packet size. Okay? Then that comes down to the internet or the network access, and that's how it gets out. Whether it's an IPv4 or IPv6. Does that make sense? Y'all see the flow down there? EIGRP can be configured to authenticate routing information. Well, what is EIGRP? Is it a dynamic routing protocol? How many think it's a dynamic router? Dynamic routing protocol. Or is it static? How many of y'all say it's static? How many of you say it's dynamic? Those that raise their hand for dynamic are absolutely correct. It can authenticate, can be configured to authenticate routers or routing information. Ensures that routers only accept updates from routers that have been configured with the correct authentication information. So in other words, if Jordan and Derek are trying to communicate and they talk in 2 different languages, are they ever going to be able to communicate? No. That's why if Derek is OSPF and Jordan is EIGRP, are they going to be able to communicate and find out information about each other? Absolutely not. If they're both EIGRP, can they find out information about each other? Absolutely. Okay? EIGRP has 5 different types of handshake protocols. Okay? The hello, my name is Scott, and I'm talking to Casey here. What would be her protocol? She would use an acknowledgement saying, hello, her name is Casey. Okay? And then after 5 minutes, we'd do it again. Hello, I'm Scott. Okay? That's what we call an update query, or update. Now, if I don't remember her name, I say, what's your name again? You catch it? You'll see how that works? And her reply would be the response to the query. The hello and the acknowledgement are your initial configuration, or your initial communication, I should say. Your query and your reply are secondary type of communication. What's your name? Okay. How are you doing, Joseph? What's your name? Okay, well, you're looking at Wireshark and it was running, right? How many times do you say, looking up for DNS information. Y'all seen that, right?
Yeah.
Same idea. It's querying that DNS server for that information. That's all it does. Once I recognize it's Marlin, I said, okay, this port's going to Marlin. I may forget it in 5 minutes, but I reestablish the communication. They're used to discover the EIGRP neighbors. That means EIGRP, Josh and Marlon and Casey and I are all talking on EIGRP. We can send them as IPv6 or IPv4 multicast packets. What does that mean? What is a multicast? You send more than one, but does it go to everyone? Multicast does not. It goes to the specified users. Think about it, it is an email that goes to a variety of users, but it's not broadcasted to everybody. Broadcast is everybody. Multicast is a group of people. Unicast is singular. Okay? The IPv4 multicast address is 224.0.0.10. So if you see that one coming around on your Wireshark, what do you know? What do you think? Is it a good thing? Why would it not be a good thing? Because it sends it every 5 seconds. Wouldn't you hate to be the next router that has to answer those every 5 seconds? And you wonder why we always get bandwidth always filled up. It's because these stupid hello packets. Okay? What happens is, in this instance, router 1 and router 3 can communicate to router 2. Router 2's network behind it can no longer communicate. So router 2 sends an update message to router 1 and router 3 saying this network is no longer here. They respond with the acknowledgement saying, we understand. Does that make sense? You have 3 different types of sending and 2 different types of receiving. Right? What are your 3 types of sending in EIGRP? And query. Hello, update, and query. What are your 2 responses? Acknowledge and a reply. Good job. Update packets are sent to propagate information to that network only when necessary. It sends partial updates. A partial update only gives you what? Partial information, or the information that you need. What is bounded updates? If that router is affected by this networking going down, it's called a bounded update, because that router is part of that traffic. Does that make sense? Updates use reliable delivery, therefore they require an acknowledgement. Okay? So I pick up the phone and I call Casey. Remember, when we're talking about the difference between TCP and UDP, TCP is a connection-oriented protocol. I pick up the phone, call Casey. Casey's on the other end. She's answering it. I say, hi, I'm Scott. And she goes, hi, I'm Casey. That's an acknowledgement, right? So she has acknowledged it. Updates are the same way. I'm sending you an update. By the way, your house is on fire. Thank you for the information. I'm leaving my house. Okay? Usually they wouldn't do that. They would drop the phone and run. You'd hear the phone hit the floor, and then you know that you got their attention. Let's talk about a query and reply. R2 is querying, looking for reliable networks. Let's say router 3, the traffic, or router 1, the traffic over here also can come out to a router 4, which can go up here. So router 2 is trying to find the best way to get traffic over there. So it sends a query out, router 1, router 3, do you know where it needs to go? If not, remove it from here. So they'll reply back, either they know another way to get to it, or if they don't, they say, okay, thank you. That's what a reply is. It's like a guy querying a girl. Hey, you want to be my girlfriend? I don't think so. Okay, that's that response, right? The guy was querying if she was available. She responded, I don't think so. EIGRP messages. Remember, they're all encapsulated. So they have 4 different types. You have your data link frame. What does your data link frame do? What level is a data link? Data link is not on layer 4. Not on layer 5. Not on layer 3. It's on layer 2.
Well, see if you do.
Well, that's 4 questions you got wrong in your final. How about that? The MAC address. Layer 2 is broken into 2 sublayers, right? Your data link layer, you have what? You have your dynamic link and MAC, media access control, right? That is the physical addressing area of your network. What about the IP packet header? What layer is that on? It's on the network layer, right? Why? Because it's a logical address. What about an EIGRP packet header? Do what? It's on the transport. Very good, Marlon. Why? Exactly. It's how where the session information from the TLV types gets sent down to the EIGRP header, which took over for what kind of headers? What are the other 2 types that you would have on a transport layer? What protocols? UDP and TCP. You also have EIGRP. You also have OSPF. Those are your routing protocols that are on that transport layer that establish where that IP packet is going to. Y'all catching on now? Is it starting to click now where you're seeing how all these pieces of the puzzle fit together? Getting there?
We're missing the OMG and the OMFG headers.
-6 on your final. Okay, now we're going to talk a little bit about how to configure IPv4 EIGRP. All you have to do is give it an autonomous system number. The autonomous system number is given to you by the IANA. The IANA is responsible for all the addressing, and there are only 65,535 autonomous system numbers available. Before you can use EIGRP, you must get your own from IANA. Okay? And that's for external to your network. They could care less about internal to your network. You'd never use EIGRP on your internal network anyway. You'd use static. ISPs require autonomous number systems from the IANA. ISPs also use what we call the Border Gateway Protocol, which you would get into when you get into your CCNP. Yes, Derek?
So on that IANA, does it cost businesses money?
Oh, yeah, betcha. I would be venture to say, because I've never bought one, but it cost a ton of money. It would be like you buying 100 T1s. The people that use EIGRP are going to be AT&T. They're going to be Cox. They're going to be Sprint. Major corporations. They figure there's only going to be 65,000 companies that want to do it anyway, so. Do what? When they run out? That's why you have OSPF.
So it's first come, first serve.
Are you by Cox's or AT&T's? Okay? All you have to do, for what you're going to do in here, you're going to use one for quite a bit. So, router, EIGRP, just like router RIP, right? Router, RIP, we give you the RIP. Router, EIGRP, and the autonomous system number. So, router, EIGRP 1, and you're in. You set up EIGRP. Congratulations, right? Not quite. The router number is used in both of the protocols. It's considered a router's ID. It's more significant for you in OSPF than it is in EIGRP, and we'll get to that. I've got to give it a router ID number, which is that router's specific IP address. So it'd be EIGRP, router-ID, and give it the IPv4. Okay? You can make it whatever the loopback address is for that router, but it has to specify that router. If you have not already configured it, the highest would be your loopback, the highest loopback address possible. Okay. So what you do is you go into interface loopback and give it loopback 1, and go IP address, IPv4 dash address, and a subnet mask. And they kind of screwed that up because IPv4 should be in italicized. Because it's IP address, and then the IP address and subnet mask. All right. EIGRP. All you're saying is from this router, I can get to all these networks. That's all it's saying. I can get to network 172.16.0.0, network 192.168.10.0. So anything that's going to the enables EIGRP interfaces for subnet 192.168.10.4/30, it would be 255 or be going to 192.168.10.24 is what you would see right there. So anything. Remember, we talked a little bit about how you can stack multiple ones together, like in Packet Tracer 2, where you had your .16 and .17. You had to do your route summary. So instead of it being 24, you went to 23, so you could put two of them together, right? Same idea. These are going to be summary routes. That's what that network is. I'm giving me my summary route for that network. And then I can do a log neighbor changes. What that does is if it notices that router 2's EIGRP routing table gets changed, it'll automatically change it in ours. Make sense? When you're looking for the network address, you have to give it a wildcard mask. Wildcard mask is a full subnet minus your subnet. So if I'm looking for a network to specifically identify a smaller network, it would be network 192.168.10.0. If I didn't want it, which would have been what? 0.0.0.255. Does that make sense? Because my subnet mask is 255.255.255.0. So subtract that from 255.255.255.255, that leaves me 0.0.0.255. In this case, they want it down to the /30. /30 is the .252, so it's 255.255.255.252. That leaves me with 0.0.0.3. Does that make sense? Are you with me? Chris, you look out of it. Marlene, you okay? Yeah. Casey? Darren? All right. Use the passive interface command. Oh, y'all love passive interfaces, don't you? A passive interface. It prevents neighbor adjacencies. It suppresses unnecessary network update traffic and increases security controls. It's preventing unknown rogue routing devices from receiving the IGRP updates. What does passive mean? It means it's not going to allow the data to be sent out of this interface. It's only going to receive it. Does that make sense? So if I want to make router EIGRP 1 passive dash interface type and interface number. Fast 00, right? That's it. So I'm specifying that my passive interfaces are these interfaces. Okay? So when you're looking in your show EIGRP neighbors, we have two different networks here. We have the 10.6 and the 3.2 out of the two different serials. We have hold time of 11 seconds and 13 seconds. And we have our uptime that tells you how long it's been since that went down or before it resets for the whole time. Okay? Any questions? This whole time right here is saying, before I check and send my next hello, this is how many seconds I have left. This is how long that system's been up on my network. Y'all with me? Show IP protocols command. It will show you what, yes, I know. It shows you what commands are there. In this case, we're looking at EIGRP 1, right? That was the autonomous system number. Our router ID is going to be 1111 in this case. We have a distance, internal distance is 90 and our external is 170. That's the administrative distance we talked about a while back. Automatic summarization was disabled. And then here are our distance and our update times. So you can get all that information off of show IP protocols. So if I had OSPF running as well, or what other protocols I may have running, you could see that. Okay? Our routing table, remember D. What does D stand for? EIGRP. Okay? So when you see a D, you're talking about EIGRP. In this case, 172.16.2 network with a subnet of 255.255.255.0 is connected to the 172.16.3.2 serial 000 port. So if I need to go to the 172.16.2 network, I've got to go out my serial 000 to the 172.16.3.2. Since this is 90, what does that mean? The administrative distance is 90. What does that mean? No. 90 means it's an internal EIGRP. 170 there would show you that it's an external EIGRP. It's external to my network. Yes.
Okay, so on the bottom one that's highlighted there, okay, the times and the 90 and the distance are the same. What would happen if, say, they're both the same distance and that one and the times are off?
Okay. All this is saying right here is my 192.168.10.8 network can be gotten to via the 192.168.10.6 serial port or the 172.16.3.2 serial port.
So if the times are off, then we would...
They're not times. These right here,
Yeah.
they're just saying that this network came up for both of these at the same time.
Oh, okay.
It's probably when that was plugged in on this end. So I could go out either one of these connections to get to where I need to go. That's all that's saying. The operation of EIGRP. Discovery. I call Casey. Hello, I'm router 1. Is anyone there? No. You say, sure, here's all my information. I'm router 2. Is anyone there? Yes, here's my routing information. Now we're sharing information, right? And all I say is, thanks for the information. Here's my routing information. I'm using Split Horizon. You say, thank you. Now we know how to communicate. It's pretty simple. Get to know these formulas. You will see them on your test, and you're going to have to write them out. Just kidding. I just want to see you squirm. Okay? These are what we call metric weights. All they do is just give you that big long number that you saw at the end of it. Okay? It tells you what your bandwidth is, your delay of your interface, the reliability, the transfer and the receive loads. I don't ever worry about them too much. When we talk about our interface, we did bandwidth of 64, right? 64,000. Y'all remember that? Now you understand where it's coming from. It puts it right here, the MTU size. It says my MTU is going to be 1,500 bits or 1,500 bytes. That is how long that packet is, 1,500 bytes. I'm sending it at 64 kilobits a second with my delay of 20,000 microseconds with a reliability of 255 out of 255. That means perfect reliability. If anything drops, forget about it. And my transfer and receive load is 1 out of 255. That's all it tells you. Any questions on that? This is how you would troubleshoot it to find out if something's wrong.
What's
Yes.
the RX? Is that
Receive. And there's your interface delays. So if it was 20,000, like it's showing on there, a delay of 20,000, it's going to probably be a T1. That would be my bet. Because this is a serial connection. That makes sense. Which is faster, serial or fast Ethernet? You sure about that?
So fast.
Faster than that.
This is
It
fast.
only has 100 microsecond delay.
What about a gigabit? How'd you like to be able to do all your homework in 10 microseconds? You know, that's quicker than a blink of your eye. All right, calculating the IGRP metric. You're going to determine the slowest bandwidth that it possibly can use, and that's 10 million divided by that bandwidth. All right. If our bandwidth is 64,000, right? You're going to divide that. Then you're going to put in the sum of delay divided by 10. So what is our delay? 20,000 divided by 10 gives you what? 200. So 200 plus whatever 10 million divided by 60. Do 10 million divided by 64,000.
$156.25.
156.25 plus 200.
Times 256.
$256.25.
Okay, now multiply that by 256.
91,200.
So 91,200, that's not, we're any close to that, is it? So we're using a faster one, right? For this metric. But anyway, that's how that metric goes.
You're using 1024 for that one.
They're using 1024? Okay. So 1024 is what? Oh, there. I see what you're saying. Diffusing update algorithm. It talks about loop-free paths and loop-free backup paths. It does fast convergence because you're doing dual things at the same time. And then we also have FSM, which tracks all routes coming in and out of EIGRP to find the most efficient way of sending traffic. You all understand that? The feasible distance is the lowest calculated metric to reach that destination. That's all it is. Then we have the successor, which tells us the least cost route to that destination network. It tells you which one's going to be the quickest way to get there. If they're the same, if you have two different ways to get to the same thing and they're both identical, which way are you going to do it? You do load balancing. Just send them from either one. Let them get on the other end. Feasible successor is a neighbor that is a loop-free backup path to the same network as the successor, and it satisfies the FC. The FC is met when the neighbor's reported RD, or reported distance, to a network is less than the local router's feasible distance. RD is an EIGRP neighbor's feasible distance. All that to confuse you, right? RD is the reported distance is the EIGRP's neighbor's feasible distance to the same network. So if Casey and I are both trying to get in touch with Jordan, we look at our table. If her distance is the same as mine, then I go to the feasibility condition. If it's less than. Look at the feasibility condition. If it is met when a neighbor's reported distance to a network is less than the local router's feasible distance. So it's feasible for me to send the traffic over here if it's less to go from her out, right? So the condition has been met. So then I would send it to her instead of directly to Jordan. In other words, if I have a T1 line here and she has a T1 into Jordan, but I only have 56K dial-up, is the feasible condition met that I want to send traffic to Casey to send to Jordan?
So is it kind of like the quickest and shortest route?
The most reliable. That's what you're looking for. The administrative distance will be shorter, and it's going to be so long as you can meet the same or better circumstances to get the data there. All right? I'm not going to get into that. Here's the example. Remember we have the 1.0/24. If I'm going out serial 001 out of me and go to Casey to the 192.168.10.6 network, it's feasible for me to get it there, but R2's distance is much bigger. Which way is the traffic going to go? It's going to go out the normal one, right? Because this serial 000, because this number is greater than this one, is not feasible. Does that make sense? And I'm not going to make you go through this process, but you can look at it if you want. IPv6 is identical, just on how you type it in. So it's going to be interface 0, serial 000. You can give it IPv6 address instead of the IPv4 link local address or the local host. Once you assign the address, you click exit, go to that interface for each interface that you're assigning it to, and then it just says that IPv6 interface brief is all up, and that's pretty simple. Okay, how do you do IPv6 on EIGRP6? So you say IPv instead of router EIGRP2, it's IPv6 router EIGRP2. You just add IPv6 in front of router EIGRP. Okay? Any questions? And it's going to be the exact same thing with IPv6 in front of IPv6 EIGRP2. All you're doing here is assigning EIGRP2 to that interface. That's it. It was just 2 is that autonomous system number, just like the 1 was for IPv4. They just want to separate it so you can identify it. And it's the same thing for the rest of it. Is there any questions on chapter 4? Remember, 90 is for external or internal, 170 is for external. Hint, hint, hint. Okay, we're going to talk about advanced EIGRP configurations, and I'm not going to talk about troubleshooting it. Okay? We're going to talk a little bit about automatic summarization versus manual summarization. If you auto-summarize, it's going to screw up your CLI. As you type, it's going to kick you to the next line, and everything's going to get haywire. So you just got to continue typing. Y'all remember those things that just pop up when you administratively turn something on, and it'll pop up and you'll be in the middle of typing something else and screw you up. Automatic summarization does it every 5 seconds and posts something out there. Okay, just giving you a heads up. We're going to configure router to propagate the default route. We're going to talk about how to modify and configure the EIGRP. All right, here's what we're going to look at. We're going to talk about 1, 2, and 3. This is all in the autonomous system 1. And what you're going to do is you're going to say, R1's going to say, I'm going to send an EIGRP IPv4 router automatic summarization to our router 2. Remember, we talked a little bit about router summarization, right? What does it do? It converges the multiple networks into one higher layer order, right? So if I'm going by 8s, anything from 0 to 8 or 0 to 7 will be in that range, right? Correct? All you have to do after you do your router EIGRP with 1, just type in auto summary. That's it. It will summarize your routes. That's how quick it is. Those 2 words, hyphen together. And always leave it at non-auto summary unless it tells you to auto summarize. Okay? We're talking about IP protocols. Show IP protocols. This is showing EIGRP topology all. Route summarization 172.16.00/16. That means any network that's in the 172.16.00 or 172.16 network all the way to the 172.17 network will fall underneath this, I'm sorry, if you're trying to get to the 172.16 network, you can go out the 192.168.10.5 or the 192.168.10.9. The route summarization, like I said, anything that's coming out of 1, 2, or 3 is still underneath that 172.16.00, right? So all those networks are directly connected to that one. Now, you can get to them in a variety of ways out the 10.5 or the 10.9, right? But all of them are summarized underneath that one network. It's pretty simple of what we were doing, right? With subnetting, how we were summarizing those networks. Anything that would fit underneath that would be put in. All right, I'm not going to go through this little part. Manual summary. This is what we talk about supernetting and taking an aggregation of multiple networks and putting them together. Instead of typing Autodash summary and it doing it automatically, we're going to manually do it. How do you manually do it? All you got to do is on that interface, IPv summary-address, EIGRP, whatever the autonomous system number is, and then the network it's going to reside on with its mask. Isn't it a lot easier just to say Autodash summary?
So are there any benefits to doing it manually?
Only it's not going to continue doing that on you. It's just set. But what happens if you set it manually and something goes down? That's why auto summary is better. But it's just a pain in the butt to type on the command line. So always turn that on last. Right, Cody? I remember seeing his face and a couple other people's faces when we did auto summary. They're like, no, stop! Seriously, that's what the whole class was about that night. No, stop! It made people think I was doing something to them while they were walking by. Beating them with a whip or something. Again, a manual summary is going to show just like it would if you did an auto summary. The only difference is for IPv6 is IPv6 summary address EIGRP, in this case 2 because we're talking about IPv6, and you give its address and mask. That's it. And so you'll see it like this. And if I want to propagate it, I've got to redistribute, right? If you do it manually, in order to propagate it to other routers, you have to redistribute it. So that's another command you have to type in. So is no auto summary pretty good? It saves a lot of headache, doesn't it? All right. When you have the D, that just means it was learned from an EIGRP. The asterisk means it could be the candidate for the default route. In this case, it is the default route. Why? Because anything going out that port, or anything, will be going out that port. EX is the external EIGRP route. In this case, it's going to be our summary route going out that external port. And 170 is the administrative distance. Why? Because it is external. Good. You learned something today. So if I want to do EIGRP default route, what's the default route? : /0 or -0, right? /0. And then the interface is going out. So IPv6 router EIGRP2, which is saying we're initializing EIGRP2. We're going to redistribute it static. It's going to redistribute that static default route going out to 010. And if I want to specify more parameters, I could say the metric is going to be 64, which is our bandwidth. 2000, which is our what?
Delay.
This is our delay time. What's 255?
That's leftover out.
Wildcard route.
Can't think of the name.
No, it's not the wildcard mask. Reliability. What's our 1? No, transfer and receive. 1500. MTU. Remember, those are the metrics that are on that. We're specifying all the metrics. What if I want to do a bandwidth percent? IP, bandwidth dash percent, EIGRP, autonomous system, and then you tell it it's percent. So if I said the bandwidth is 64,000, but I want to cap it at 50% for this trunk, or for Cody's port, I want to put it at 1%, he gets 1 of 64,000, which means he gets 640 kilobits a second instead of 64,000 kilobits a second. I'm mean, aren't I? Yes, Derek.
So is this what they talk about metering?
Throttling.
Yeah, throttling?
This is
So
throttling.
throttling?
IPv6, bandwidth percent, EIGRP, autonomous system number, percent. And Cody, just because you're so nice, I'm going to give you 100% bandwidth for IPv6 because no one uses IPv6 addresses. And I don't do DHCP over IPv6, so therefore, if you put an IPv6 static address out there, you're going to get all that bandwidth. All right? You can set the hello interval by changing it by IP hello-interval, EIGRP, autonomous system number, and how many seconds it's going to be. The whole time you can set being 180. If it's greater than that 1.544, which is your basic your T1 line or less, T1 is not 1.544 or greater. Ethernet is. T1 is 1.544. You can set it to whatever you want, but these are the defaults. Okay? So quickly, you look at it and you see my whole time is 5 seconds. What am I going to say? I mean, my hello interval is 5 seconds. Is it a fast line or is it a slow line? What do you think? It's fast. Load balancing. Maximum paths in the value. You can have up to 32 paths going out. By default, it's set to 1. Load balancing is disabled. If I set it up to 2 or more, I'm now load balancing, right? Because if I have one path, can I load balance? No, because everything's going down that trunk. I'm water hosing it, right? If I have two water hoses. Now I can balance that water coming out, right? How many of you have ever done a Y splitter on your water hose and you see that the percentage of water coming out is lower on both sides than it is if you turn one off, then you get all of it out that one? That's what load balancing does. It's not good for watering your yard, but it's good for throttling bandwidth or load balance traffic. Routing protocols such as RIP version 2, EIGRP, OSPF, ISIS, and BGP all support various forms of the message digest 5 or the MD5 algorithm for security. You can see that on Wireshark or any other packet tracer, or packet sniffer, I should say. You see it on any packet tracer. So you want to make sure that you're using things in a cryptological format. All right? How do you do it? You create a keychain by giving it a name. You're going to give it a key ID, and then you're going to give it a key string text. Okay? How do you configure EIGRP with it? Well, you go into that interface. Once you already have your key chain set, then you can go into the IP authentication mode, EIGRP with the autonomous system number, and say that it's going to be MD5, which is you're telling it, you're now going to do it on MD5 authentication method. How many of you have ever downloaded something that says validate the key here, the MD5 hash, right? Then we're going to go into IP authentication, the keychain, the EIGRPR number, and then you're going to give it the name. Does that make sense? Y'all with me? Pretty simple. And here's an example of it. If the keychain is EIGRP underscore key 1, key string is Cisco 123. I'm going to exit, go back to the serial interface. IP authentication mode EIGRP1 MD5, and I'm going to use IP authentication keychain EIGRP1, which is the autonomous system number. They highlighted a little bit too much there. EIGRP key, and then exit. So unless you know my key string is Cisco 123, any traffic coming out of the serial is going to be in an MD5 algorithm. All right? And it's the same thing with IPv6. You just put IPv6 key. Pretty simple. Verify identity. Any questions on that? No questions? Items, concerns, corrections, complaints? You'll be reading for your final, right? All right, again, your final will be a multiple choice true-false test. You will have 60 minutes, and it will, I'm not going to tell you how many questions I'll put on there yet, because I don't know. It will cover up through OSPF.
And you said you'll be putting out a study guide.
Yes, I will. And it'll probably be up sometime tomorrow. If not, by later tonight, if I don't forget. Are you happy now? The problem is I'm not going to inflate your grade for you filling the packet tracer now. So whatever you get, what you see is what you get. WYSIWYG. All right. Your bonus points for your attendance will come in handy. And that'll be the end of that. Any questions? All right.